Assalamu alaikum, everybody. Good morning.
Good morning. Good morning.
Yeah. It is with a great honor to be with all of you once again in ETC Talks, since we are all here today to benefit from another interesting topic. Before I will introduce our guest speaker for today, let me reiterate for a few reminders. The session is recorded and questions may be raised after the discussion. Our guest speaker is currently the Associate Dean Enterprise at School of Science at Loughborough University. He has more than 2 decades experience as senior management in academia and well experienced in digital imaging. During this period, he earned many rewards and significantly contributed to the development of many SMEs. He has a master's degree in digital communication systems and a doctorate degree, both were taken from Loughborough University in United Kingdom. Dr. Ali Al-Hardi, the Dean to the University, would like to welcome our guest speaker. Dr. Ali?
Yes,
Thank
good
you.
morning. Thank you, Mahfouza. Good morning,
Dr.
Dr. Iran. And
Yes.
thank you so
Thank
much
you.
for joining us. To be frank with you, I was trying to fix the camera issue since I didn't use it for a while. Anyway, hopefully to meet each other physically very soon in our next visit to UK or your visit to Oman. Uh,
Yes.
Yes, on behalf of the University of Technology and Applied Sciences in the Sultanate of Oman, we're very glad to join us on the series of talks organized by the Educational Technology Center at the Higher College of Technology. Let me give you a brief about our system. We are around 13 colleges amalgamated by the Royal Decree 76 over 2020, which was issued last year by His Majesty Sultan Haytham. And these colleges specialized in providing technological education to the students. Majority of our students are Omani. Mainly, we are awarding our students up to bachelor degree. We have advanced diploma and diploma as well. All the certificates are designed to fulfill the needs of the labor market in Oman and abroad. So welcome to the University of Technology and Applied Science, and thank you so much for joining us on this series of talks. Um, I'm sure yeah, your talk today will be so informative and will be a talk which will really help our team to uh, to include some of your input in the future planning. The topic which you will cover today, along with your academic background, is of very high value to all of us. Um, Oman adopted a strategic plan in last year, and this plan, I mean, the design and the planning of this strategic plan has started roughly 5 or 6 years ago. The plan is trying to forecast the future needs of this country, uh, uh, capitalizing on the capabilities of its human, of its geographical location, and of all the economic and social contents of the country in order to come up by 2040 with a result that aims to establish an economy of knowledge, and also to achieve the uh, you know a lifestyle which will be pleased to all the Omanis. Education considered to be the cornerstone of the whole of this plan, but employing the contemporary concepts of fourth industrial revolution is one of the pillars which the country going to employ in order to come up with the desired results. So, yani, thank you so much for joining us, and I'm sure this will not be the last. I mean, to meet with you, Prof, and
Yeah.
definitely, we are looking forward for further collaboration and further projects. Projects that will really help us to cooperate and to come up with something good for the whole country. So thank you again on behalf of the entire team, passing the regards of His Excellency, the Vice Chancellor of the university, and wishing you all the best.
Th Thank you. Thank, uh, so, thank you very much, Dr. Al-Hardi. This is it's a great pleasure to be with you, presenting some of my work, which I thought will be the most relevant to your organization. Of course, Higher College of Technology, as it was called at that time, is not new to me, and I visited you maybe 3 times and have, I think, supervised maybe between 12 to 14 of the PhDs who are now perhaps working there and serving your university. And I'm very happy to know that you have got a university status, and I'm looking forward to a visit in the future. So the topic that I selected was based on a project or 2 projects that I am doing with 2 organizations based in Dubai, and the subject area will of course be valid to any Gulf country. So I thought this is a good way for me to show how I have worked with these organizations to develop various technologies. Now, I must tell you that the Dubai Desert Conservation Reserve is owned by Emirates Airlines, and they are a research organization, whereas Falcon 9 drones is a SME, and so their needs are very different. So you might see in my presentation, I am not going into a lot of detail. Of course, I don't have time for that. But if someone wants to know more, I'm more than happy to explain. But if it is a project with Falcon 9 drones, I might have to contact them because of confidentiality issues. So I also work with Side University. Actually, it is one of my past PhD students who is working there and who uses his students to capture test data for me to work from the UK. So I'm from Loughborough University, UK. This is an aerial image of the university. It's a very green campus situated in the East Midlands, right at the center of the UK. So it's a very familiar place to, I'm sure, some of you who are in the meeting right now. So this is Dubai Conservation Reserve. It's an area that equates to 5% of space within Dubai. So that area, and it's quite a big area, and they always struggle to actually monitor this entire region because it's practically not possible to manually do it. So what they normally do is they have their drones, various kinds of drones, mostly the most famous Chinese brand of drones, which is one of the top brands anyway, is called and the DJI drones, and they fly them. They capture data, and when the drones come back, a drone normally has about 17 minutes to 30 minutes flying time. So during that time, they get back, they download the data onto a computer, and then they manually analyze these images. So when they discussed this with me, I said, why not try using machine learning, deep learning, to see whether we can help this process. So the Dubai Desert Conservation, if you Google the name, you will find it. Also Falcon Eye drones, you will find them as well on the internet. Falcon Eye drones they are a company, SME, recently bought by a big company, but they are still an independent unit within that big company, and they do government contracts for urban monitoring of urban areas, mostly urban farmland, for various purposes. So I am helping them as well. So you will see some examples from my work with these two organizations. So we signed MOU with DDCR in 2020. And they are working on support. So the purpose of the work was to support their desert conservation work. What they do is they breed endangered animal species in captivity, and then they slowly and carefully release them to the desert areas, and then they look after them. So this has been a hugely successful project, because some of the Arabian oryxes and gazelles were almost extinct from their desert areas, and now they have plenty. So this is a very successful project that has run for more than 5 years, but my involvement with them was 2020. Now, just if you look at the dates, remember all of this research was done remotely through the pandemic, and my students who worked with me were in different countries. So it's an amazing thing, and I think this is the way in future we could do research. You don't have to be in one place. So we completed a number of projects in up to last month, and I'm going to just show you some of the results. So detection of groups of animals, single animals, and also tracking them. And also detection of Guftries. Those are trees that that's their national tree. So I don't know whether I'm pronouncing it right, but I hope I'm right. You will be in a better position to know. But we also would be working on counting and locating the trees or objects that are at ground level. And with Falcon Eye drones, the project is slightly different. It's because they work on monitoring urban farmland. And so their interest was to detect green areas, detect windbreaks and crop areas. And I'll show you some results. Detect palm trees. Of course, they also want to detect groups of animals, but farm animals. Locating and counting palm trees is another project. So some of the work that I'm describing is research, and some work is more developmental in nature. So the research is more pure research, and the development work is more closer to the application. Okay, so just if you look at, I know this audience consists of people who know machine learning, deep learning, and also students, staff, and maybe other officials from various organizations as well. And I was just thinking, how could I pitch this talk to benefit all? And I'm just going to take you through a story. So hopefully that will explain everything in a very simple way. So how do we detect? So my question is, how do we detect and recognize and also count objects? So detecting an object, recognizing what type of an object. So detecting an object is to say that, okay, there is some object there. Recognizing means what type of an object, and of course, counting or measuring. How can we do this using drones? Now, one thing, the way that they have been doing it, both organizations have very successfully over a 5-year period done that with drones, and they fly drones. They get the video footage, and then people sit down and analyze, count, measure, and come up with answers. And it's a very time-consuming task, especially for the SME, Falcon Eye drones. They started as a small company, but they got more and more projects from the government and also from Saudi Arabia and few other Gulf countries, and they couldn't handle it. So they wanted automation. So I will come to that. They were thinking that off-the-shelf software will work, but unfortunately they did not. And I will explain to you why. Then also, uh, let's look at how computer vision can be used and how machine learning can be used and artificial intelligence, especially deep neural networks. Now, I picked up these three words: computer vision, machine learning, and artificial intelligence, especially deep neural networks, because there's a finite, very fine difference between the three words, and it's very important that we all understand that. And it's not easy to difficult to understand it because this is the way human brain works. So let's take an example. Okay, so what is the difference between computer vision, machine learning, and deep learning? So I was trained as a computer vision engineer. My PhD and soon after my PhD, the initial PhD students I supervised were all in computer vision. So I was working on the fundamental aspects of how can we detect and recognize an object, where I will tell the algorithm or the system what features to extract. I will set the rules to be able to classify them into different types. So I'm going to do it. So I'm going to write a program or use a existing program for feature extraction, but I decide on the feature extractions. I decide on the rules that are used for classification. Okay, this is not the easiest way to do it. It's very fundamental. It's the most fundamental way of doing it, right? Then of course, then came machine learning. Machine learning has been there for many years, but there the instead of using rules, uh, you can you can get a classification algorithm, a classifier, to come up with the rules. So for example, in the first case, computer vision, a rule could be so when you extract the features, you get what is called a feature vector, and then you set up a rule saying that if this is a car, the difference of the feature vector of the new car with the car in the database has to be a certain distance, and it has to be lower than that to be a car, right? It's just a rule. But classifiers will learn the rule. So it's just that we just have to select the right classification algorithm. So yes, we extract the features. We have to explain what features to extract, but we can pass on some of the tasks of automation to the classification algorithm. The problem still is that selecting a classification algorithm is not easy, because the classifier that will work best will depend on the features that we extracted, right? And also, extracting the features for a particular application, say for example, detecting a car or detecting a human, is difficult, because from object to object or from problem to problem, the features that we could use to try and separate or classify object types will be very different. So you have a problem. You have two problems now, right? So you have a object detection problem, and you want to detect, or object recognition problem. You want to recognize an object, but you have to decide on the features to extract. Of course, the classifier will work, but the classifier will depend on the features. Features will depend on the input images. So from problem to problem, we have to be involved in this design process. So the biggest problem is that feature extraction and classification were separated out, right? And what deep learning did with the advancement of technology is that they brought it together. So these two were combined together, and it happens together now. So networks learn the features to be extracted and the way to classify based on those features. Okay, so let's take this example. I give you a picture of a cat, and you are trying to recognize that this is a cat. obviously you will agree with me that the very quick thing that you will do is you will look at it, right? As soon as you look at it, your attention is taken by the shape of the cat, right? Now, which means that it is taken by, if you go into a bit more detail to see what your brain does, it does an edge detection, right? And the edges alone, so if I give you the picture, the edge detected image, you will still tell me that it is a cat, right? So a simple edge detection allows us to recognize that it is a cat. So we could say then, okay, go and detect the edges, and then we use a support vector machine. There are we use a classifier to classify. There are different kinds of classifiers. Okay, I'm not going to go into details of that, but that is the purpose of the classifier. What does deep learning do? Now, remember what here we did was we picked up the features. Based on the features, we are able to now have an idea of the shape of the object. And our brain has been trained to say, if the shape of the object is like this is a cat. We don't really mind even if the cat was of a different color, right? Because we will know by the shape and the size, aspect ratio, and all of these things, even the posture, right? Even the way the cat is standing, that this is a cat. Okay. So what did I just say? I said we are doing this recognition based on shape. We are doing it based on edges. Then edges will give us an indication of shape, right? Because edges get connected and then they form the shape. And the shape and a bit more about a posture, right? That is a bit about our knowledge about how a cat would be seen normally. All of these things are a bit of things that our brain has learned. So if this can be done within a neural network, now neural networks have been there for many, many years, right? 30, 40 years. But recently, with the advancement of computing technology, especially GPU computing and multi-core computing technology, it was possible that we could actually have multiple layers in a in a neural network. So that makes it a deep neural network. So what a deep neural network does is it is able to extract features, let's say, for example, color, edges. It could be like, I think if I show you the next slide, right, this is better. So initial layer could be just picking up the edges, or color blobs, like a blob. Blob means like a shapeless and a shapeless area, okay, but it has some color. Then of course edges, right? Then also we might have various shapes. Remember, shapes are made out of things like edges connected together. So when shapes are connected within a cycle or something like that, it becomes a circle, it becomes a straight line, it could be any other shape of an object. So that's another intermediate layer. Then of course we have more abstract concepts like, so for example, at the top level there, top layer, you will see if it is clear enough, you will see a human face coming up, a shape of a car coming up because there is a wheel, right? And shape of an animal being created little by little. And now if you look at all of these layers together, now I have not told this network to extract edges, extract color, extract shapes, extract more high level features. Let's assume that the network is so deep and the network has all the freedom to come up with all these features, right? Then you will agree with me that once the features have been extracted, it might be an unlimited amount of features. They can be put together, right? Provided we have trained the network. So we have given similar images. So for example, we have given images of cats, dogs, right? These are animals, or humans, cars, and we have trained. So what the training would do is it will try to understand how these features at different layers are combined together when an object is formed. So it becomes an easy task because I just said that the network will learn how the features are combined together. That is the classification because we have trained it. That is where the classification comes. So it's called supervised learning. So you give examples of objects and it will learn. Now this is the nice thing about these deep neural networks, right? Now you might think, and most people, I'm not saying you, but most people who are not necessarily fully aware of computer science and some of the sub areas of computer science, they would think, okay, I can do deep learning, I can do machine learning, and then they will get into trouble very soon because really this should not be considered as a black box concept. Okay, so let me move forward quickly. I'm going to show you a lot of examples now. So this is a building block of what is called a convolutional neural network. So the type of deep neural network or the type of neural network used for image analysis is called convolutional neural networks. Images are 2D, two-dimensional spatial objects or spatial data formats, and there is a relationship between adjacent pixels that forms the image, right? So a convolutional neural network normally includes multiple components, and what this picture shows are the basic components. So you'll have so for example, you have a convolution layer, and then followed by a pooling layer, another convolution layer, another pooling layer. Okay, so you will see that the convolution and pooling comes together, right, as pairs. And at the end, you might have many of these layers, so 3, 4, 5, but then finally they're all connected, right, to get the outputs. So what a convolutional layer does is that it actually extract lots of features, right? Now, what pooling does is that pooling uh, reduces the feature space, because when you extract features, if you extract too many features, you're not necessarily going to need all of those features for the classification task. Some features will be useless, okay, and they need to be dropped off. So you reduce the dimension of the space by doing that. Now, usually we could have multiple layers of feature extractions that will allow us to do more and more difficult classification tasks. So for example, if you tell me, can you separate out a camel from a dog or a cat? I wouldn't need that many layers. But if you say that there are different kinds of dogs, and I want you to separate out the different types of dogs depending on their breed, then there's going to be a difficulty because it's similar object, very similar object, and separation between these different types of dogs, breeds of dogs, will be very fine, and therefore you might need detailed feature extractions, and therefore in a case like that you might need more network layers. Okay, so there are many examples, many important aspects when you talk about convolutional neural networks. And so you saw the convolutional layer, pooling layer, and fully connected layer. You might hear the word hyperparameters. Hyperparameters are parameters of a network. Like, for example, how many convolutional layers are you going to use, right? Then what is the optimization technique you are going to use? What is the loss function? There are various aspects that you can set before you even start training a neural network for a particular purpose. These are called hyperparameters, okay? And epos are like when you train a neural network, uh, each iteration of training across the entire data set that you're training it with, right, is called one epo. And every time you run iteratively the training task, the network become more and more accurate for the task that you are training it for. So if you run it for more epochs, you are going to most probably get a better result. Not always. So you have to be careful there. Okay. And we also use what's called data augmentation and transfer learning. And I'm going to come to those things later. Okay. Now I need to go a bit faster. So there are different deep neural networks used for different purposes. And the networks that we are using is because my examples are all around image detection and recognition, right? What we are using is what's called YOLO version 5, okay? But so what is different from image detection and classification? Okay, so if I have given you separated out or cropped images or closely cropped images of animals, cars, buses, right? And now if I tell you recognize them, it is an image classification task, right? But if a scene has got a car, a palm tree, a camel, right? And I need to go and look for in the whole scene and pick up an object and say what type it is. It is an image detection task. So it's not just saying what is this object because the object, sorry, what is this scene? What is this picture? Because the picture consists multiple objects and you need to detect an object and then classify. So this is the difference between various image detection networks like RCNN, SSD, YOLO. They are the most frequently used, and they are very similar, but they have got different advantages. The one that works best from my experience with all of this work is YOLO version 5. Version 5 is a very latest version that has got lots of additional features. Okay, so it's not my network. Somebody has, some people develop them over years, and I'm trying to use these networks for various cases. Okay, I'll show you a few examples now. Okay, so first of all, the first project was detecting a group of animals. Okay, so here you have the case where this is a drone image, and you see that the animals are very small. Okay, so what we do is we capture rectangles like this, right? And these are our training rectangles. You will see that in each of these rectangles, the animal density or and also the shape of the rectangle is very different, right? So it's very important that when you are doing training, you understand how the deep neural network works, because initially we did the mistake by always having square shapes or rectangular shapes of the same aspect ratio. And this was, we were trying to do something that is very restrictive, that did not allow the neural network to pick up a group of animals who will be in a different formation or in different densities. Okay. We also use something more than what YOLO does. We are using the sliding window approach. I don't have time to go through that, but if you get a large image, normally the images that we capture from drones will be very, very large, but these neural networks can handle only images of YOLO 5, can only handle 608 by 608 images, 608 pixels by 608. So therefore, if you feed it, now this is a mistake a lot of people do, they feed the whole image. So if you have a 5,000 by 3,000 image, they would feed the whole image, right? Of course, you're going to crash the memory, but at the same time, it's going to fail because it will not work. It will refuse to work because the YOLO 5, YOLO version 5 can only deal with 608, 608. So you need, so what it will do, if you give a big image, it's going to resize it, and the animals will become even smaller. So this is something that people get trapped in some cases. Okay, so these are some of the results of the detections. Now you will see, I will show you when the drone goes up, so this is at a different angle. Here the drone is looking vertically down. You will see that the animals are small. Now you see that some animals have been missed out. That's okay, because we are just looking for a group of animals. Okay, so where we can define it as a group, there are more than two animals in a square area, then we could say it's a group. So look here, and it's even smaller because it's further and at an angle. So it is still able to detect all those things. It will draw rectangles and say that's a group of animals. Now, we have trained this deep neural network to detect any group of animals because at this size, and during this project, we were not bothered about what type of an animal it is. Because at this size, it's always also difficult to recognize what type. So here, the whole purpose was detecting a group of animals. Okay, then we went on to detecting single animals, the same concept, same process, but the labeling required us to label single animals. Now, you will see that when you're training the deep neural networks, it has got lots of additional tools, additional functions, things that you can use. One important thing is called data augmentation. So say, for example, you have animals all looking in one direction, right? Then you can flip the animal, you can rotate the animal, you can do various things and feed it in. So these data augmentation algorithms are already implemented within the deep neural network environments that you can use. If you think that you need a particular augmentation which is practically required as a computer scientist or a programmer, you should be introducing that. Otherwise, the deep neural network will not be able to handle that. Okay, so here these are detections of single animals. This is a very easy image to detect single animals, right? Because animals are big, they are separated out. Now I will show you more and more difficult ones, and our accuracy goes down. Okay, this is still good, and now it's good. You might see, if you are very careful, that we have missed some animals in this area here. And then here we are missing them because the animals are too small for detecting as a single animal. So this is why we came up with the group of animal detector, because at this size you can't pick them up. Um, okay, so there are few observations. Now, what I always say is that if humans, if we can detect an object, if we can recognize an object, then we can train a deep neural network to do that. In fact, um, it has been proven that deep neural networks, if trained properly, can do better than humans. In international competitions and large-scale experiments, 5% of the data used, with 5% of the experiments done, people prove that deep neural networks can be better than even what humans can do, right? But there's a big but. You need to know how to train the neural network. So this is the experience that most people need to gather nowadays. Okay, so this is we haven't had good pictures of camels to train, because remember, if you are going to train a neural network to detect animals that are very small from very low resolution images, you need some examples of very clear, very big, high resolution and same kind of animals, because you need to mix that data with the low resolution data, because then the neural network learns, having seen the low resolution animal and the high resolution animal, it tries to find out the similarities at different scales of resolution, and therefore it will learn that even if it is shown a very low resolution picture, that it is a camel. Okay, we haven't got that many camel pictures, but we still have got a good level of accuracy here to detect, because this is a project that is ongoing. So you will see that these are bigger camels. It's easy to detect, more accurate, and you will see a number. You will see a number in front of each one. Sorry, in front of each animal. And what that means is the confidence score. So how confident is the network to say that it is that sort of an animal? So high figures, zero 0.9, says that it is very confident it is. So here we look at this camel here is lying down on a side. Initially, because we did not have images of camels lying down, we didn't get them detected, but then we got a few examples of them. The neural network, we trained it further with few examples of these animals lying on the side, and it was very accurate after that and was able to pick up those animals. And and we did we have just completed a project with gazelles. So these are gazelles detected as at different um, distances from the camera, from the drone. This is from vertically from the top. You also, I would like you to give a bit of attention into the fact that you can also see the shadow of each animal, but you will see that the shadow is not getting picked up. And this is something that is important when you're labeling an image. You should try not to include the label, include the shadow inside the label, because if you do, it's going to put a rectangle around the shadow and the animal, and it becomes all very complex. Okay, but I'm going to give you some examples of what not to do when you're labeling. So shadow, keep the shadow out if you want to detect various animals. Okay. And then we were able to also look at using what is called a Centroid tracking algorithm. This is a deep neural network that we developed, a very simple deep neural network, which actually tracks the centroid of each of these rectangles to try and connect one frame to the other. So even if the animals are crossing each other, it will be able to track, so detect and say this is the same animal. I will show you some videos. Since I don't have that much time, I'm going to just show you one video. So this is a video where so first of all, our oryx detector detects the oryxes, puts them in rectangles. Then our tracker takes the rectangles and tracks the rectangles. You will see that even if the animals cross each other, they are still detected as separate animals. It might not be the case, but in most cases it is very accurate. Okay, and remember, this is multiple objects being tracked in one go. This was in 2015 and 16 when I was doing my machine learning work. This was impossible to do, and you see how good and how well it is. Okay, so we have completed the projects for. So I need to stop this now. Go back into my presentation. Oh, sorry. I think I. Okay. So we have done camels and gazelles as well. Camels presentation is here in this, but gazelles was also here. It's too big. I couldn't. It was some gigabytes because it was like a 10-minute video, and I couldn't crop it. But I have the content if you want to see. Okay. Then we also did a Guftry detector. This is a very new project, not yet completed. So this is a very easy case of detecting the Guftry, right? And this is a more harder case. You will see that we have missed the small trees because I told my student who was working on the project, ignore small trees. But we are now trying to bring in the small trees. We always do this very carefully. When we do training, we do stage by stage, trying to understand what goes wrong and try to solve, and then try to improve, and then again find what goes wrong next. So so this is a new project, and hopefully within another week or so we will get all these trees picked up. So since I can detect these trees now, I can find the centers. The drones capture the GPS information, therefore I can pick up the center, the GPS position of the tree if we want to. Once again, Dubai Desert Conservation Reserve wants us to calculate the size of the trees based on the canopy area. And it's easy to do because we just try to find the area of the rectangle. And that will give not the canopy area, but includes the background as well. we are working on using our green area detector. Once we have detected the rectangle, to remove the non-green part and then say, okay, what is the green area? So our green area detection is very capable of removing shadows. So you will see that, I haven't come to that because, yeah, so sorry. Okay, so I have got, then with Fed's project, we have worked on a green area detector. So here the problem is that we have got images, they have got different shades of green, right? If you look at these are windbreaks, these are cropped areas, there are some palm trees. Each of those have different green. Look at this area where the crops are very small. There is an element of greenness. If you try to do the green area segment, now this is not deep learning, this is machine learning. If you try to do separate the areas using red, green, blue colors, it's an impossible task because you can't get a machine learning algorithm to, or a classification algorithm to learn from 3 color parameters because they are overlapping color spaces. If you convert the RGB into HSV, the only component that will contain color is hue, right? And saturation is like how bright or how light. So if you have a red color, which is very light red, that means saturation is high in that. If you have a red color which is very dark, like blackish red, like the trees, and when the trees are in dark areas, the leaves becomes blackish green. When you look at them, you think it's black, but it's not, because it's the value that has become high that has driven it to look like black. But actually, if you look at the hue component, you can separate it out. So what we have done here is using the HSV color space and a very famous classifier, very frequently used classifier called the support vector machine to classify. So this is how we did the training. So we picked up various examples of green areas, took the pixels from them, converted the RGB values into HSV, fed the support vector machine, and then we had the negative samples, non-green areas, right, including shadows as well, and it learned from that. So here we were very careful in the green areas that we were not working with shadows. Look at the green area. Some of the green areas we picked up are very different because this is green but more brownish green. This is like more from a Guftry. So this is that result. So this is what has happened. So we pick up the green areas, and then we did a shape analysis to identify long strips of green regions. So that's what it is. Then we also did a crop area detection. Now this is back into using deep learning. So the company wants us to detect crop areas to find out in which farms people grow crops, and this is our attempt to detect them. And you will see here this rectangle, this second rectangle, because we train on samples of that type of greenness, it was able to pick them up as well. Okay, moving on to a project that we finished long time ago, because this was our first project, the palm tree detection, that we have this system now working from the Amazon web server for the company to use. So all that they do is just upload an image and it will give the answer. So we got it running from the Amazon web server, and a very similar approach. These are the results. Now, I just want to bring your attention into few things here about the trees where the background has got crops, right? And the trees where the background has only sand, right? If you want both type of palm trees to get detected, you need to have clear palm trees and also some samples of palm trees with crops underneath it, because otherwise it will miss out these type of palm trees because it doesn't know that how to separate out the palm tree from the green crop. So we were able to do that, and our accuracy is really high. We once again here palm trees where they are dying, like these type of palm trees, we've ignored them in the training, so we are not getting picked up. We have about 99% accuracy in palm tree detections, and the company has already tested this because they are using this for their commercial work now. So this is another image. One of the things that I'm working with them now is to so the bigger project I have with them is why only palm trees, why only certain type of objects, but let's go for maybe detecting this type of sheds and houses and things like that. So I have got a video here. So this is our ultimate goal. If you see this video, this is what we want to do. This is just a mock-up we did before we started the project to tell the company this is what we are aiming to do. So any object that we see, we will tell what it is. Okay, this is our ultimate aim. In doing this, we have now completed some of the tasks. So we are going to finish them very soon. Okay, so here this is an example of multi-object detections, but we are now working on improving each of the separate object detections, and our aim is to build a single classifier that will classify all of these different kinds of objects. Okay, I have got some other research area that I have focused on, which is to see how deep neural networks can be used in improving image quality, especially denoising images, improving the resolution of images. Historically, this was my main research area. So some of my work that has gone into the mobile phones that you're all using now is me working with my PhD students and a company, and we use machine learning. But so now that deep learning has come through, we have converted all of that into deep learning, and actually they are much better. So this is an example of how we could improve the resolution of an image. So you have a low resolution image. If you want to improve the resolution, we have trained a neural network to improve resolution, right? It's a completely different subject area. And the type of neural networks we use for this is different. They are not convolution neural networks. So and also here, this is denoising, removing noise. So even we don't need to know what type of noise has been added. We can train a neural network to remove them. So we are working on a number of follow-on projects. This is a full list. Counting animals, we are doing it, and they want us to look at animal behavior analysis. So when we track the animals, we know their movement patterns. We can identify, detect the behavior. That is with the DDCR. They have different species, and we are trying to give them a single network that will be able to detect single any kind of animal. They are also recording night time. So one of the things that we are working on is that if you see a oryx during daytime and nighttime, could the same algorithm be able to do it? I'm confident yes, because we can do it, right? And therefore we can train the neural network to do the same. So there are lots of projects which are beginning, and these are the with DCR, the 4 types of animals we are immediately going to focus our attention. Just an indication of the computer we used. So each of my PhD students have an access to a machine similar to this. So it's the NVIDIA GeForce 380 processors, the graphics cards that they have. I can give the full specification if someone wants. So these are the machines used by the PhD students. So they train them on them. Recently, since all of my PhD students have returned to their countries because the situation in UK was not good, and they've been remotely logging into the machines and using them. Okay, so a few very important conclusions. And a piece of advice as well. We should not consider deep neural networks as black boxes. This is the problem. I can tell you many stories, but a very, very simple thing. When I started the project with Falcon 9 drones, and they were recently bought by a big company, and I met with the the owner of the CEO of the company, and he said, "Look, what you're doing is not rocket science. Anybody can do it. Why should you get it?" I said, "Okay, if you're not interested in my work, leave it. You do it, right?" And he said, "Oh, you can buy off the shelf software. If you go to Amazon Web Server, the software is there. All these neural networks are there." But I said, "Okay, do it." And he came back in 2 months saying, "Please, can you continue to work with feds, because we need your help." The thing is, the expertise there is not necessarily designing the network; it's how to use the network, and you need a lot of experience there. So that is what my team has gathered over the past years. But we are using and we are changing the networks as well now, because we understand how they work and where they do not work. So pre-trained neural networks require careful retraining and using. Yeah, so deep neural networks are actually challenging humans. So where is the technology going to move now? And I'm going to leave this talk with a question. Okay, so at the moment we are doing deep neural networks. It is working fine, right? What next? What is the immediate thing that is going to happen? People are working on what are called self-learning. Now you saw that I was teaching the neural network by labeling, but neural networks are now being taught to self-learn. So these self-learning neural networks are becoming popular. In another 2 years' time, they will hit the ground, and then machines can start learning themselves. Then it becomes dangerous, because machines can create their own intelligence. This could go completely out of control. This is like a sci-fi movie. And therefore, a lot of people now have got into working with ethics of AI, because it is becoming a bit dangerous now. Now, processing, can the classical computers that we use now help us with solving all the problems? Perhaps not. Quantum computing is coming in a big way, but maybe it will need 5 to 10 years. And when quantum computers come, all of this will change. It's a massive steps change there. And it's not a step, it's a massive change. And therefore, we could look forward to that. So quantum computing with self-learning neural networks, this is going to make it completely revolutionized. Okay, my work was supported by a few PhD students. So the first student has completed the PhD and gone back. This student was from Saudi Arabia. The other 3 students are doing the research. Thani is in the final year, writing up. The other 2 are rather new. So they are working as a team. At the moment, the 3 people are in 2 countries, and as you can see from the names, they have been working with me over the last year with the companies as well. So we meet once a week, a 1-hour meeting, and then we catch up everything, and then during the week we share data, we share ideas over email, and the students work with me separately to develop the algorithms, and then we send it to them for testing. We are always interested in not only doing research. This is something that I always value. You need to do research that actually has a practical application. So I do not stop after I finish research. I work with the companies or organizations to help them to practically make use of them. So we do desert conservation, the DDCR. We have provided them the software. I'm now working with them to help them integrate that software into their own software packages. And the company has already done it, because they have the capability to do it, and they are using it commercially. I was supported by these individuals from DDCR and Syed University. Andrew, some of you know him because he were with me in my team doing PhDs. He is one of my PhD students, and he works for Syed University in Dubai. And he's the one who takes his master students and record video footage for me. Then company, these 2 individuals, including the CEO. Okay, so that's us. Now that brings the talk to an end. So my contact email address until end of July is this, but I'm leaving Loughborough University after 25 years of service and joining Keele University it's a difficult decision for me, but I was looking for my next career move, and I think it's time. But Kiel is a university that is focusing on sustainability, and this is a huge topic for them. And I'm taking my team with me to Kiel, and I will reestablish research. So there's a bit of a disruption that is going to happen in July. But after that, I will reestablish myself. But it will be my team who will then be working. But I will just keep an eye on what is happening. So I think that brings me to an end. If you have any questions, thank you very much for listening. I hope I made it interesting and I kept it simple, but I know that lots of details were left out. You might have questions about what is the accuracy, what happens if this happened, that happened. I have got presentation slides and I can explain. So I am happy to answer any questions now. If I can't answer things as questions, you have got the email addresses. Please only write to Loughborough account if it is before 31st July. After that, if you want to keep my email address, the second one also already works. Okay, thank you very much.
Yeah. Thanks once again, Professor Idrising. Yeah.
You're
Now the
welcome.
floor is open for question and answers. You may raise your hand if you have any questions. Let us see if there are any hand raised.
I can't see any hands raised. Maybe
Even
uh,
myself, I cannot see
yeah,
any hand
you
raised.
can you can speak up. You might be, it might be lunchtime or it might be prayer time or I don't know. But if you have any questions, please ask.
Yeah,
Otherwise, I'm happy to
yeah,
answer.
we
Yeah.
have we have one question because it's also a session classes. So some of
Yes.
them maybe
Yes.
could have attended some
Yes.
classes. We
Yes.
have a question from Miss Ilham.
Oh, yes. Hi. Hello. Can I can't hear you.
Yes, Miss Ilham, you are unmuted.
Assalamu alaikum. Thank you very much for the very insightful presentation.
Yeah. You're welcome.
My question is, how, if at all, how would a process chemical engineer or
Yes.
environmental engineer
Yes.
fit into this type of a project at whatever level it may be, if at all?
Yes. So for example, you saw me applying it on desert ecology or desert conservation, but the tools are the same. So for example, it might be the case process chemical engineer. You might necessarily not be working with convolutional neural networks, but you might have to use other neural networks like LSTMs, which are more geared towards working with data for data mining, data processing. So, but the neural network, the principle is the same. You just need to learn about that neural network and the architecture and what are the inputs, what are the inputs. So even if you work in a project like that, that knowledge is transferable because my students who work in a particular area, I tell them you're doing a PhD or you're doing a master's project. It's just a project, but what is important is for you to understand the fundamentals. So how I'm answering your question, I think anybody should be freely getting involved. But the thing is, sometimes you might not have the understanding, the computer science fundamental knowledge. Now, therefore, you might think that, okay, I'm using deep neural networks as a black box. But if you work with a computer scientist who understands the internal processors and processing, then you will soon learn to be a specialist application scientist in your area of specialization. So that is also very important. Did I answer your question?
Yes, thank you very much. It makes sense. So just to clarify on the last point, so at some point eventually, would we need to have some background and training in computer science to understand how to use these programs? Or
No, no. I would say no. If you can work with computer scientists who understand the processes, it's about intuition after that. As a human, what would you do, right? So when you're so if you are someone coming from a different area, then you want AI to use as a tool. Then what you need to do is understand how the human brain works, because that is how AI works. So you don't need, but I think it would be good to have one project with that where you will get some experience working with some people who will understand. Otherwise, you have to read and understand. So at the moment, I have a mechanical engineering student and I'm helping her to recognize cricket balls, and she hasn't got a computer science knowledge, but because she worked with me for now 2 months or 1 month, 1.5 months, she's beginning to understand, because everything makes sense, so I think others can learn, but they should not think about it as a black box. That is where the mistake is. Okay.
thank you very much.
Any other question?
That was the only question. Just scroll down to see if more questions, if more hands are raised. Yeah, we have another question.
Yeah. Hi. Hello.
Yeah, let me unmute
Hello.
it.
Hi.
Yes.
How are you?
Yeah.
Thank you for a very fruitful presentation, Professor. You've talked
You're welcome.
about the neural networks.
Yeah.
Did you try the reinforcement learning?
So the reinforcement learning is used. So we are using, because we are not processing data here, right? So we are using convolutional neural networks, because we are working with 2D data, but we are going to use reinforcement learning for some other applications. So for example, I said that we are going to do animal tracking, and we are going to do behavior analysis, right, of animals. Then we will bring in data mining based learning algorithms for data processing. So that is where we are. That is why we have just focused on convolutions, because convolutions are the basic operations that we perform on a 2D space, on 2D space. Did I answer your question?
Yes, you did. Talking about the reinforcement learning, it comes to a stage where it is a bit scary, if I may say, because it learns a lot more than it should. I don't know if you can slightly brief us about reinforcement learning. It would be great.
Yeah. So what that okay, so let's take, okay, so let me tell you, you saw an example, you saw the example where I showed you that we have used we have removed noise, and we have improved the resolution. Okay. And the approaches we use there is not convolutional neural networks. We use kind of more like reinforcement learning type of thing. So what that does is that you are given a target, so you're reinforcing your learning. So all these neural networks. So the basic principle of a neural network, there is a forward propagation, which means that you are given a target, and you're learning, the network is learning how to approach a target. Then when the target is met or achieved, always the target fails, right? And then you need to look at how what is the error, and that error can be fed back. So you have what is called back propagation. So when you have a back propagation channel, then you can go back, reinforce the learning, because you know that you achieved something but not perfect. So you can reinforce that, support that training, retrain with changed parameters, and you can improve. Okay, so what happens in the reinforcement learning is that you're actually trying to achieve something little by little. It's like so for example, the super resolution creation that I showed you, where the resolution has improved, what we have done is we have shown the neural network very high resolution images and their own versions of, purposefully image. So we took very high, like 8K, 8K, 4K images. We converted them into HD, and we gave the 8K or 4K image as the target, and we let the neural network learn. So here the processes is that it has got this approach where it continuously learn, and it changes the learning process. In convolution neural network, something similar happens, but we normally call them convolutional networks. So there is some sort of reinforcements happening there, but it's a different way of, it's the way that the parameters are set and way that the feedback is given back to the network to retrain is a bit different. So normally when you say, okay, let's use reinforcement learning, that is mostly you're talking about supervised learning and in data science side of point. So that is what happens.
Okay, thank you very much.
Thank you. Anything else? There's another question.
It seems that there is no more question.
I can see a hand up.
So,
I don't know.
Is it?
No, I think it was Asma or
Yeah.
something.
No more questions. Seems it was well explained. The topic was well explained. Yeah. So we shall end this session.
Okay, thank you.
At the end of this very interesting session, join me to thank Professor Aaron for a fruitful session on application of machine learning and artificial intelligence to drone imaging for desert conservations. Wish you all the best, Professor, at the Keele University.
Thank you. I will make it a point to visit your university within the next year, definitely.
Inshallah, inshallah. It was interesting to know that you've been here for 3 times.
I think it's 3. I think my past students would know how many. I can remember walking in twice at least, so it could be 3 or 2.
Okay. Thank you. Thanks. Bye-bye.
Okay. Thank you. Thank you for inviting me, and wish you all the best, especially for the students with your studies. And yes, so please send me an email if you want to get to know a bit more about. We have got few papers out. We have been very careful about submitting papers due to the fact that some of this work is commercially sensitive. So we had to get approval from 2 organizations before we publish. But we've got some publications, and some are being written for publication. Okay, thank you.
Professor.
Thank you. Bye.
Bye.